So once we are online, Rene, just give me about 30 seconds to give a quick intro, then the stage is all yours. Okay, I'll just give a quick intro and then.
Sounds great.
We are online. Let me just, let's just wait 1 more minute, Rene. I'll just send out the YouTube link everywhere. So I will go on mute and you guys can kick it off. 1 more minute. Let me post it everywhere. Let's start.
No,
Yep.
I
Let's start.
yeah. Okay.
Hey, Priyanka, you want to start with the intro?
Hello, are we online?
Yes, we are.
Okay. Okay.
Start.
Okay. All right. So yeah.
Vision
Hey,
where
Rene,
we can
just a
then
moment. There's some problem with the
where we can
audio.
then bring in virtual content and persist it in the real world. Um, yes, someone is talking.
Yes. It was Setu. He just asked you to hold on for a moment.
Okay. Yeah. Should we start again from the beginning? Yeah. You want to do the intro again? Okay.
Hello? Yeah, okay, sure. Okay. Good evening, guys, and thank you for joining us tonight. We are here with the much awaited session of spatial computing and augmented reality. And today we have with us Rene, who has a prolific experience working as director of research and innovation. He's also the Microsoft regional director and MVP, and has experience of more than 15 years working with virtual reality, HoloLens. And he's also featured on the Forbes list, has a lot of accolades, is a dev influencer, and is also a keynote speaker at many AI conventions and other notable events. So with that, I leave the stage to Rene. Rene, it's all yours.
Thank you for the nice introduction. Hey, welcome. Today we're going to talk about spatial computing and the AR cloud. And in this talk, which is around 40 to 45 minutes, and then we have Q&A afterwards, we will talk about spatial computing, and I will explain what it is and why we call it spatial computing and how it relates to AR, VR, and all of that amazing stuff. And of course, we will actually cover quite a bit of AI because all of that is driven mainly by computer vision and advancements in deep learning. We will also talk about use cases. I will show you some use cases we developed, like a digital twin solution. We will talk about how we can render huge 3D models that have hundreds of millions of polygons on a mobile device like the HoloLens 2 here. We will talk about the AR cloud, which is this augmented reality cloud. Think about it, a digital content layer, a digital twin of our whole physical world, which allows us to interact with super exciting stuff. We will talk about object anchors, brand new service, Azure Mixed Reality service. And then I will also show you some intelligent edge scenarios for this so-called augmented intelligence scenario, where we can run object recognition directly on the edge on the HoloLens using a deep learning model execution on it, basically doing inference directly on the HoloLens. I will show you some 3D scanning, like how you can do 3D scans rather easily these days. And I will also show you some brand new stuff, rather exclusive now, about how you can do a 3D mobile live streaming. So a couple of things. My name, like was said, is Rene. I'm Director of Global Innovation at Valorem Reply. We are a digital transformation company pretty much focusing on the Microsoft stack, but that ranges not just the front end, but it ranges from the back end over to data analytics, a lot of data science stuff, but also Office 365, classic app development, web apps, and desktop applications, but also things like HoloLens applications, VR and AR. And we have been part of the Mixed Reality Partner Program since 2015 and developed lots of use cases since then. I'm also a Microsoft Regional Director and MVP. These are awards that Microsoft provides to independent experts that share the knowledge. So I do a lot of conference speaking. Also very active on social media. So you can find my name on LinkedIn. Feel free to connect. Also my Twitter handle, I will have it at the last slide there. So you can also connect there, where I constantly keep on sharing all that stuff. And that's being honored, right? Oh, and also I'm doing open source projects. Actually, one of my open source projects, which just featured again, writable bitmap X, some computer graphics stuff. And I'm also advising the VR and AR Association and the XR Bootcamp. Sorry for the long intro. Let's finally get started. So you probably have seen personal computing before, of course, right? And so really personal computing became a thing, let's say in the 90s. Of course, personal computers entered homes a little bit earlier, but really in the 90s is when the time was when a lot of people had it at their home. And then it really took off when they become internet connected, right? And so, that really changed how we also share knowledge. And especially with Web 2.0, we had these kind of knowledge sharing much better and much broader, in a sense of that everyone can participate, everyone can share the knowledge, microblogging, Twitter, all what we take as a given, right? And after personal computing became a thing, the dominant computing platform is really mobile computing, right? And mobile computing, of course, had changed a lot, and for many people these days, it's the first mobile computing platform, or it's the first computing platform they get in touch with is mobile computing. And so we come from personal computing over mobile computing into spatial computing. And with spatial computing, I mean things like virtual reality, VR, where you're fully immersed in a virtual world. You don't see the outside world anymore. You're wearing this headset, you see the full virtual world. And in comparison to AR, augmented reality, you can still see the real world with AR, right? And a lot of these use cases are based on mobile devices these days. And so we can see, for example, like this little figure augmented on top of our camera stream we see on the display of the phone, right? And again, in comparison to VR, you're fully immersed in VR. You don't see anything outside of the virtual world. With AR, you still see the real world, which is then augmented, right? And then we have things like a HoloLens, which is a mixed reality device from Microsoft. And by definition, you would also say it's an AR device, right? It's an augmented reality device because it's augmenting your view. And when you wear it on top of your head like this, you have these transparent lenses, right? You have these transparent displays where you can still see the real world around you, but also these sensors allow you to interact with it. And so it's by definition an AR device, but also it can sense the world around you and it can transform your room, right? It can change the walls and things like that. So it also touches a little bit of VR. And that's why Microsoft calls all of that mixed reality. But if we expand that a little bit and talk about, after personal mobile computing, we enter spatial computing. It also includes devices like this, mobile devices, right? Because these devices can sense the world around us. They are spatially aware. And the HoloLens can do that, of course, even better, right? With all the sensors it has here on the top. But even mobile phones, with thanks to AI, computer vision, can sense the world around us, right? So they can spatially sense the world. And so we're coming from this personal computing over mobile computing into the spatial computing age, because we don't just have siloed experiences on our devices again. We can basically use these devices that can spatially sense the surrounding and provide contextual information based on the real world, based on our surroundings and the environment we're in, right? And so that is highly relevant. And so spatial computing will be the dominant computing platform of the 2020s. And combined, especially with the AR cloud, the augmented reality cloud, which is this kind of digital content layer, this digital twin of our whole physical world, right? So like I mentioned, we have these devices like a HoloLens, but even mobile phones that can sense the world around us. They capture all the data, they do 3D reconstruction, but all of that is just on a single device, right? But if we take all of that 3D reconstruction from each single device and bring them together, we have a full digital copy of our whole physical world. And so we can use that as a machine readable map that can be understood with computer vision, right? So we then have this reference map, this AR cloud map, where we can then anchor virtual content. Like you can see here in the video, right? We can point on and locate these kind of panels. We can anchor these panels in the real world. And then with these devices, with these spatial computing devices, we can, and thanks to the reference map in the AR cloud, we can then relocate and someone else can load that same content at the exact same location, right? And so we're going to talk much more about that, but let me show you actually some other use cases first. And let's talk about digital twin. And I know a lot of you are familiar with what a digital twin is, but just to make sure we're all on the same page, a digital twin is basically a digital replica of a real world entity. And that's typically a building, a machine, an engine, whatever, a plant, and so on, right? And so this kind of 3D object of that real world object is, augmented with sensor data. So you have this real object that has a bunch of sensors. Like if you look at the slide here, we have a jet engine, and this jet engine has a bunch of sensors on it, right? And on my digital twin of this 3D model of it, I can see these sensor data being visualized, right? So I get insights much, much faster. And that's a huge market that also a market research company Gartner is seeing. And Gartner is labeling digital twins as a transformational technology. It's the highest benefit rating, and they see a ton of business value in that. And we also see that working with our clients, that there's a huge uptake for digital twin solutions. And so what we build here is the so-called digital twin experience, and that is visualizing a chemical plant. And this chemical plant, the real chemical plant, has a bunch of sensors inside of it, right? And so we can take a 3D model of it and visualize the sensor data on top of that 3D model, right? So we take the real sensor data from the real chemical plant and can view it here in AR in our own environment, right? And can visualize this kind of sensor data. So as you can see here, this is the chemical plant 3D model, bunch of sensors all over the place. And if we select one of these sensors, we get the real-time sensor data. We're actually using Azure IoT Hub here. So basically all the sensors send the data to Azure IoT Hub where it's being aggregated. And then on the HoloLens, we can access that and then visualize it on top of the 3D model and have our digital twin. The experience also has a second part, like a training instructions for repairing these kind of sensor boxes. So this blue box is one of these sensor boxes you can find in the chemical plant. And what we also show is a kind of training instructions, how you can open the box, how you can repair it, and so on and so forth. And that is, of course, providing quite a bit of business value because even untrained employees could then do these kind of tasks, right? Here's another piece. I figured let's talk a little bit about flight simulation as well, which we did quite a while ago, actually, for the HoloLens. And what we do here is with HoloFlight, we can visualize real-time flight data on top of a 3D map. So we have a 3D map here with actually dynamic terrain coming from Bing Maps API, which provides us the elevation data as well. And so we can visualize, these are here the Hawaiian Islands, right? So we can visualize it in 3D. And then we can also visualize the flights and the airplanes. And that airplane information is actually real time. It's coming from a flight stats, like a flight data provider. You might know these, mobile apps. They are basically using the same similar backend to getting real-time flight data. And so we can visualize it. We can also show airport information. And what we can also do is we can store the recorded, we can record these kind of flight data and then store it in an Azure backend, in an Azure database. And then we can actually download it from there and play it back at a different speed and do things like this, right? Let the trails basically stay if we play it back faster, and then we can see the typical flight routes. Let me show you another one, which I did using AI object recognition directly on the HoloLens, right? And so for this one, I used Custom Vision AI, this service from Microsoft, where you can easily train your neural networks. I know a lot of people here are AI and ML experts, so you probably wouldn't use Custom Vision AI, but just for the sake that everyone knows what I'm talking about. So you take the servers, you take a bunch of photos from an object you want to recognize, as you know, different angles, different shading conditions, and so on. Upload that to the servers, give it a label, and then you can take another object, bunch of photos, give it a label, upload that, and then you have a nice web UI, hit a button, train, and you have your pre-trained object recognition model, right? And what you can then access is the REST API, so you can send a photo to it and we'll give you a result back. But what I did is, and which is really nice with Custom Vision, you can actually export that pre-trained model in various formats, and one of them is Onyx, ONNX, which you can execute on, thanks to Windows AI, with WinML, hardware accelerated on any Windows 10 machine. And so I can take the pre-trained network, run it with hardware acceleration, even on the HoloLens, because the HoloLens is a Windows 10 machine, right? And so I can do things like this.
This might be a car wheel 3.5 meter in front of you. This might be a matchstick 1.1 meter in front of you.
As you can hear, we're using text-to-speech here basically to output what the user is seeing in front of them. And again, this is executing this deep learning model directly on the HoloLens without having to send anything to the cloud. So we get low latency, low bandwidth requirements, and so on, right? The distance you can also hear, that's actually just using the spatial mesh of the HoloLens, because like I mentioned, it has a bunch of sensors. So it has also a depth camera, so it can measure the distance to the objects basically. And that's what I'm just leveraging here for outputting the distance. And so you might wonder, why would I need that, right? If I put on the HoloLens, like, why would I care? I can see what I'm seeing in front of me, right? And the thing is, think about like people that have low vision, for example, they could use that. Or you have these specialized tools. I mean, we all know what a hammer and a power drill is, but think about it, could be specialized tools, or that could be your IKEA package, right? You buy and then you just look at it and it will recognize what it is and then actually show you how you can assemble it, right? So lots of use cases there for these kind of augmented intelligence, right? And think about, you wear it on top of your head. By the way, the video I've just shown you, this was recorded with the HoloLens one, and you get, well, near real time, it's a little bit longer, but it's definitely less than a second. When I take it with the HoloLens 2, which I have here, if I run it just on the CPU of it, I get 40 milliseconds for each inference run, right? So that's really talking about real time. Of course, still limited, right? You can probably not run your full body segmentation network, but YOLO, even with bounding boxes, should work fine, right? Alrighty, another use case which is brand new is the HoloLens 2 research mode. So you can basically set the HoloLens 2 in research mode now, which was not possible before. And what it means is basically, typically from the HoloLens, you get already the pre-processed data. So you get, for example, the spatial mesh, but you cannot access the raw camera data. That's already being pre-processed on the special silicon they have in here called HPU. And with research mode, we can actually access the camera data, the raw camera data of all these, like, a grayscale camera for tracking and also the depth camera. We can access that. And with research mode, we can then further process that. So that might be actually pretty useful here for the audience if you're doing AI, custom vision, computer vision research, right? And so if you take a look at the video here, I was in a shed nearby, and you can see when I close the door, we can still see a little bit of the grayscale cameras on top, but when the door is closed, it's pitch black in there. So I can't see anything. And so since the HoloLens depth sensor is active IR, active infrared, right? Time of flight, shoots out a bunch of rays and then measures how long it takes to come back. Here you can actually see that I can also use that for night vision, right? But of course, in the end, what you really want to use it for the research mode is like building your own computer vision models, right? Okay, let's talk about large-scale digital twins with Azure Remote Rendering, which is an Azure Mixed Reality service. So what is that? Well, it allows us to render huge 3D models on a mobile device like a HoloLens, because the HoloLens is untethered. It's fully self-contained, has all the computing built in, right? So we don't need to send, like there's no cable needed or a PC. It does all of it on the device, which also means it's limited in terms of how complex my 3D models can be. And typically what you can render with the HoloLens is 100 to 200,000 polygons. Really depends on your model, right? How big the triangles are and that kind of stuff. But this here is recorded straight on the HoloLens. And this is rendering a model with almost 19 million polygons. So you might work, how does that magic actually work here? Well, this is using Azure Remote Rendering, which takes the input from the HoloLens, like the head rotation, head position, hand input, right? Because it can recognize hands. All of that input data is being sent to one of these powerful Azure GPU virtual machines where this remote rendering engine is running that renders this complex 3D model remotely in the cloud and then streams back the rendered frames as a stereo set, as a video for the left and the right eye back to the HoloLens, where you can then see the video. Also provides the correct depth, so you can even combine it with locally rendered content, right? So you can render your UI locally and then only render this super complex model remotely. And it's amazing. There's almost no latency. They do some clever tricks with pose estimation, then late state reprojection, like warping the final result. And it doesn't even take a ton of bandwidth, right? So what we use here is around 20 megabit in my demo downstream. And they recommend 50 to 100 megabit per second, but I was able to use it also with 4G. But even with 5G, I mean, this will just take off, right? If we think about it, low latency and huge bandwidth huge bandwidth available, we can do all this amazing stuff. And so you might wonder, why would I care about it? Well, when you work with clients, especially in industry where the HoloLens being used, right, it's not really a consumer device. So you often work with clients in engineering or mechanical design departments. They all use CAD tools. They all use computer-aided design tools. And these models that get out of it are huge. They're way too large, right? And so what we can do with these kind of models is we can render them directly on the lens thanks to Azure Remote Rendering. Otherwise, before we actually had to do mesh reduction. So there has to have a person like a 3D artist sit down, remove all the details from these complex model so that it fits into the rendering budget of the HoloLens, right? And so we can skip that part and take the model as it is without any information loss. That's awesome. Here's another example using photogrammetry. Photogrammetry is a method where you can take hundreds or thousands of photos of an object, different angles, right? Run it through a software like Reality Capture, which reconstructs a 3D point cloud and in the end provides you with a 3D model of it. And these are typically also high polygonal models. And again, we can render them with Azure Remote Rendering directly on the lens without having to do any further mesh reduction. And what I also see here, especially when we talk about 5G combined with it, if we think about the future, right? I mean, this is still quite a bulky device, of course, much, much better and nice to wear. But in the end, we might want to do something like this, right? This kind of glasses. This is what we really want. And so maybe in the future, we will have a phone, like a 5G phone with a companion app that does a little bit of the processing on the device. You have the glasses. And then, the heavy lifting can be offloaded into the cloud, thanks to all this amazing progress in, in computing and cloud power, basically, and 5G, of course. So this might be the key to having lightweight head-mounted devices in the future, right? Okay, let's talk more about the AR Cloud with Azure Spatial Anchors, which is another Azure Mixed Reality service. But first of all, let me tell you why you should care about it. Gartner, again, famous market research company, is basically also labeling these kind of AR Cloud scenarios as transformational in their emerging tech hype cycle. So this is the highest rating they actually give out, right? So they say there's a huge market. And if we talk about Azure Spatial Anchors, this is an implementation for AR Cloud technology from Microsoft. They support HoloLens 1 and 2 here, also Android and iOS, right? So you can use all these devices. And if we look at, especially at the mobile, iOS and Android, we have AR Core and AR Kit, these advanced augmented realities SDKs. And if we take those in the mix, we're talking about over 1 billion devices out there that are capable of, working in the spatial computing AR cloud. And so how does it work? Well, like I mentioned, you have all these devices. And in this example, you have these gentlemen walking around that office space, each of them with their phone, right? And scanning a little puzzle piece, basically, of the office. Like just a phone, normal RGB color camera phone, no depth camera, right? And just reconstructing a small puzzle piece. And the power of the AR Cloud is really this, where we can stitch these puzzle pieces together, right? And have them all merged and have this holistic kind of 3D capturing, in this case, of a whole office. But again, if we scale it up to all the devices that are out there, we can get a 3D scan, we can get our reference map in the end of the whole world, right? And so here are some examples using that in action with Azure Spatial Anchors. And what I'm going to show you is, so basically these anchors mean you have a reference location in the AR Cloud map, right? You can anchor content, if you will. And what you will see here is, first, I'm using an Android phone to create such an anchor, right? And then this anchor is being uploaded to the ASA service, the Azure Spatial Anchor Cloud service, right? And what you can see now is recorded on the HoloLens, right? So now the anchor I created on my Android is being downloaded on my HoloLens, and it matches it into the tracking of the HoloLens, right? I mean, they have a whole different understanding of the world around them, right? Of course, this device has limited sensors, and this device, the HoloLens, has much more information about the environment. Still, I can share the same reference anchor, same reference location between those devices, right? And as you can see, it's really precise. We're talking about like maybe 10 centimeter range of variance. And that's amazing. And it doesn't use GPS, it doesn't use Wi-Fi, Bluetooth, just computer vision. Algorithms like SLAM, RANZAC, and so on are being leveraged here. And with this, we get these really precise sharing across devices. And we can share also over time, which you can see here. And so here I was in Seattle in the US and created such an anchor there, attached our company logo, signage again, as you can see here. And then a few days later, I came back to the same spot, moved my phone a little bit around, relocalized. And as you can see, it really quickly found the anchor and attached the virtual signage I put there. Also, if you look closely, like I mentioned, it's using computer vision, right? You see the challenge here for the computer vision, right? It was raining when I created the anchor, it dried up when I came back. So there's a lot of change, there's a lot of feature descriptors changed. Of course, I was clever when I created the anchor. I mainly focused my capturing effort on the fence you see on the left-hand side. So it's more of the static object. But still, I mean, if you look at the floor pattern, it changed quite a bit, and it was still able to relocalize. And again, just computer vision, right? So how does it work? I mentioned it already a little bit with the feature descriptors. And you might also wonder, well, that's taking a lot of camera phone data out, actually. So what about privacy, right? I don't want to have all of my camera data being in the cloud. And the good news is actually Azure Spatial Anchors is taking that very seriously. I know the team very well. And if you follow computer vision conference like ECCV, the European Computer Vision Conference, you might have seen that they just released a new paper called Privacy Preserving Structure Through Motion, right? They pay a ton of attention that you cannot reconstruct the real world out of the information they extract from it. And so here's actually what it does. If you look at the video, on the left-hand side, you can see the real scenery. On the right-hand side is the data that is being extracted. So these rectangles with the red dots, these are the camera frames. So that shows you how the phone or the HoloLens move through the scenery. And if you look at these green dots, these are the extracted features. These are the feature points, the feature descriptors from the scenery. And if you take that set, you can see here of these feature points, actually this is the data that is stored in a spatial anchor. And only that data is actually being uploaded, right? So no camera frame is leaving your device. All of the camera processing is done on the device. Only these feature sets, this feature point set is extracted, and that is being uploaded into the Azure Spatial Anchor Cloud, where I actually also just store a spatial hash, right? So privacy, huge value for Microsoft. Other competitors might see it a little bit differently. I cannot speak for Google that also has cloud anchor efforts, or Facebook. They're working on a thing called Live Maps, right? They might do it a little bit differently. So I don't know, but I know that Azure Spatial Anchors is paying a ton of attention to privacy and no camera frames leaving your device. All right, let's talk about use cases to make this abstract concept a little bit more feasible. And so we developed an application called Azure Spatial Anchors, which you can see here in the video, that allows us to do exactly that. So first of all, you see the gentleman using his Android phone in this case to scan the environment. So basically capturing enough information, feature points, so that I can create an anchor, right? Because we need a certain amount of information. And then you see him creating the anchor. And then take a look at the lady as she's moving her phone. And the DPR here, in this case, she's using an iPhone. And so they're standing on two opposite sides. Chris is here, the DPR is there. They can basically opposite side, but she could still relocalize the anchor. And so they're now sharing the same reference location, and which can be used then to put virtual content on top of it, right? So we can load a 3D model of a kitchen sink in this case. And then we can also real-time interact with it. That's not part of Azure Spatial Anchors, but for the real-time interaction, we're using Azure SignalR in Azure. You could also use Photon from Unity. But anyway, ASA is providing you the initial reference location, right? And then you have the same reference location. Then you can try out things like this at a 1-to-1 scale in AR. And the cool part is you can share it cross-platform and over time. So you could even save it and tell someone, hey, come back later at a time. I left the 3D model there, just scan around and do that. So huge business value also in the enterprise field, of course, right? And like I mentioned, you can save these sessions, and this is what you can see here in this video, where I actually saved the session in front of my house. So now you can see me scanning a little bit around, right? Finding enough information so that it can match and relocalize the anchor, and then it loads the 3D model rather fast. And as you can see, that's a 3D model of a wooden Easter bunny, and the real wooden Easter bunny sculpture is there on the right-hand side. And so you might wonder, how did I create that 3D model? Of course, as you can see, it's a 3D scan, right? But I didn't have to use any complex volumetric capture studio, which of course would give me a perfect quality, right? But this quality is also quite decent because this was done with this phone, right? So that's a phone that has a depth camera. It's actually a Samsung S20 Plus 5G, and it has a depth camera built in, a time of flight camera that can do 3D reconstruction. And this 3D scan was done with a built-in app just in a minute or so, just moving the phone, orbiting around the subject, and then I had the 3D model. And that is awesome because I can easily create these content faster, and then I can move it around, right? And I could tell, my uncle makes these wooden Easter bunnies, by the way. And so I could tell my uncle, hey, go to my house if you have time. I left the larger Easter bunny there. You can take it as a reference map, because you can even use a real matchstick, right, and put it next to the AR object, and you can measure it and do amazing things like that. But yeah, I mean, it's a great time where we can really use, we could even do 3D capturing on a mobile phone device, right? And here are some more. So this was done with my S20 Plus, like I mentioned. Actually, the 3D scan of myself here was done by my 12-year-old daughter, right? So it's as easy as that. So what you can do with that is, well, you can do some weird things like, put yourself as a 3D model in the garden. So this is with the HoloLens. And like I mentioned, the HoloLens has this spatial mesh. So it has a understanding of the real world. And so you can also have objects physically interact with it, right? Of course, that's just some fun scenario. You would also do some other more serious things with it. Good. And what you can also do is, thanks to the depth camera, you can live stream it. And that's rather something exclusive preview I'm going to show you here about a thing I'm working on about mobile live streaming of 3D data. And so it's a little bit rough still, But what you can see here is data that comes real time from this phone, but this video is recorded on the HoloLens. So I can see the 3D data in real time on my HoloLens, right? And the HoloLens video recording, the MRC, is a little bit shaky. So you can see it's a little bit shaky, but here you can see like, front of a car, and I could help someone remotely, right? Because if I put on the HoloLens, I can see the data from the phone, not just a 2D video, but a 3D video, right? So here you can also see the phone, right, as it's capturing the data and being visualized on top of the HoloLens. So I can provide remote assistance much better, right? So I can have an remote expert put on the HoloLens, the other person just use their mobile phone, show you the issue, and you can resolve it better because you can see stereo 3D, right? You see stereo 3D with the device. So you can really sense and feel the depth and the 3D-ness of it, which you cannot see in the video here, right? That's a recent update just recorded today with this, because now we actually get the full resolution from the depth camera. And as before, it was a little bit more low res. Now you can see it's more high res. And when I stop the streaming from the phone and just walk around a little bit with the HoloLens, you can really see that this is 3D, right? And again, still early research, still working on that. But if you're interested, I can tell you a little bit more about it. Again, 3D streaming from a mobile phone. So basically your mobile phone becomes your Kinect, and you can visualize that in a HoloLens. You could also visualize it in virtual reality. But again, it provides you a stereo 3D, which you can then use for remote assistance scenario and a couple of other things. We're also seeing immense progress with AI deep learning models for 3D reconstructions, as some of you might know. And there was just a paper released at CVPR that takes a single photo, so just the photo you see on the left-hand side, and creates a 3D model out of that. I mean, what kind of magic is that, right? Of course, it just has trained data for certain people, so it's missing one important detail here, right? But maybe if I take a few more photos, it would actually also include the men one. Who knows, right? But amazing progress in terms of AI. Also, let me show you some really cool stuff with a mobile app called Clone, so Qlone. And Clone is a really nice app because it works on any mobile device. You don't have to have a mobile device with a depth camera. Any iOS or Android device works, where you can do 3D scanning. So here you can see the final model that I did with the 3D scanning there. And then you can view it in augmented reality. And the awesome part is it's animated. I mean, look at this. This is fully automatic 3D scan animated. It takes a deep learning model that is trained on previously animated models of humans and animals. So it can animate, like characters with 4 legs or 2 legs, but it can do that or fully automatic. So you do the 3D scan, and then it can fully automatically rig and animate the model, right? So here, for example, is another one with a little figure, Playmobil, if you know it. And look at this, it's animated, and had a ton of fun with my kids, actually. But seriously, that's super useful, right? For creating content rather fast. 3D content creation is always a challenge. And of course, you will still need 3D artists, right, to be clear. But that can be pretty useful for, quick proof of concepts and that kind of quick solutions if you just want to try out and show something. 3D object tracking. Let's talk about that for a second. And so there's another new service called Azure Object Anchors that allows us to take 3D models as anchors in the real world, right? And so here I got a nice video from my friend Oyvind Soroy from Bouvet that did a nice use case using Azure Object Anchors on top of a car. So basically what you do is you take a 3D model of that car, and then this becomes your AR marker, right? Instead of using a QR code or an image target, actually your 3D model is your pattern for the target recognition, which means in the end, you can actually, your real car becomes your marker, right? And so you look how fast it works, right? It really fastly recognizes, okay, this is the car, put the 3D model overlay on top of that. And they're also using Azure Remote Rendering for, remotely rendering that complex 3D model. They also integrated the Tesla API. So you can see a couple of, information. You can see the battery status. You can let it blink or even honk.
Okay, now come honk.
So that's pretty cool, actually. But again, the main thing I wanted to show you here is Azure Object Anchors that provides you 3D tracking. You might have seen that from other companies like VisionLib or Vuburia Model Targets, where again, you take a 3D model of your real world objects, that's being used for the recognition, and then it will lock the rendered 3D model on top of the real physical object, right? Okay, let's talk a little bit more before we're getting to the end here about some more AR Cloud use cases with Azure Spatial Anchors, right? Where I can anchor anywhere in the real world my stuff. Let's talk about urban murals and digital art, right? So you see this nice graffiti, but it has this ugly public parking sign on the top right, you can see there. And so we can enhance it and bring in some virtual content, right? Because the whole world becomes our canvas. So we can put some AR content on top of it, anchor it there, and just leave it there. And someone else with their phone can see it at a later time. So we can bring in our good old friend Clippy. And we can have Clippy in 3D now. And I hope I'm not showing my age. If you know Clippy, yeah, there was a virtual assistant Microsoft had in the 90s, but joke aside, there's serious use cases. Think about all these all these social media applications, Facebook, TikTok, Instagram, Snapchat. All of them have these face filters and other AR filters. For example, in Snapchat, you have these Bitmojis, right? These nice avatars you can make. And then you also get a 3D model of these, and then you can put them, an animation of those in the AR. And right now you can just share a photo or video with your friends. But imagine if I could put this AR figure in the real world and then share the location with my friends and tell them, hey, I left this funny figure there. I left this funny character there. Go there, check it out. Should be fun. And so that's actually what Snapchat is working on, right? It's really what I've been talking about since 2 years, maybe now. Snapchat recently announced at their partner summit a thing called local lenses that's using a SnapML for really making the real world your canvas, right? I don't know what Snapchat is actually using under the hood for their AR Cloud technology, but I guess something custom built. But it's awesome, right? We will soon have these kind of where the real world becomes our canvas and we can share it across time and across devices. Okay, let me show you some more experiments with Azure Spatial Anchors and anchoring content in the real world. So I live in Dresden in Germany, and there are some old video clips from 1946, for example, from the city, basically. And so what I did is I extracted some of these clips and put them in the real world and anchored them at their real world location. So I can build these kind of historic time machine portals into the past, right? So here I can see this exact location as it is now, and I can see how it was looking in 1946. And so look at the two church towers in the background, right? So the city here was heavily bombed in World War II, so it looks quite different in many places. And so as you can see, for example, this church was not rebuilt, and so there's a different house now there, right? And so again, with this technology, with this spatial anchors, I can put an anchor there, attach whatever asset, 3D model, or in this case, a video clip, how it looked in the past, and I can look in the past, basically, right? And that's quite exciting, and I keep on building those more and more. And here's something for our AI enthusiasts here. I'm working with Eddie Wu, who helps me to, he has a bunch of AI models and a pipeline build, basically. And this is the same footage I've shown you before from 1946. And it takes, as you can see, it's 4K now. It's 60 frames per second, interpolated from 15 frames per second, and it's colorized to a really nice color. I mean, that's exactly. So you see how it really feels like you have been there before. Like when you view it, and this was done with a mobile device, but even better if you put it with the HoloLens and you see it there right on the spot, it feels like you're time traveling kind of. And yeah, think about, all these tourist attractions. We can put them all over the place, persist them there. Then someone else can come with their phone, scan a little bit, whoop, loads the content, and they have their portal into the past. And you can even visualize recent history, if you will. So I do quite a bit of cycling, and here in my area, we also have some dams and water reservoirs. And the issue we're having here in East Germany is really the drought. It's really dry. It's not really raining a lot, and so a lot of these water reservoirs are getting less and less water, or having less and less water. And here you can see a photo overlaid, which I took 1.5 years ago over the current situation. And you can really see this kind of environmental change. And yeah, that we need maybe to do something about it, right? Okay, final pieces here regarding spatial anchors is about wayfinding, right? So think about can put these anchors, but I can also connect them with each other, right? It would build a graph under the hood. So I have one anchor here, one there, and so I can enable wayfinding scenarios. Now, imagine this case. There's a factory, machine is failing in a factory. Lady or gentleman in the control room see a blinking LED. Oh, machine XYZ is failing. What they need to do at the moment is they look through a lot of instructions, manuals and so on. And then they need to go to the machine, maybe take a blueprint, take a look at the information there, and then try to repair it. Now imagine we enable them with a mobile phone app or a HoloLens app. They just put it on, it recognizes what kind of sensor it is, what machine is failing, dynamically loads wayfinding information using Azure Spatial Anchors, shows them a green arrow in AR, right, on the floor, it guides them to the machine. On the machine, we can even show them repair instructions. And that could save minutes. And even if it's just saving seconds, downtime, that can mean hundreds of thousands of dollars or euros that's being saved with this kind of tech. So huge business value. And I just talked about visual content on top of these anchors, right? But it doesn't have to be. It can also be audio content. And we can use a thing called spatial sound, which allows us, if we're wearing stereo headsets, to hear where sound is coming from, right? Your brain knows where it's coming from, so you immediately turn into that direction. So we can put these spatial sound snippets on top of these anchors. And that's what Microsoft did as part of their Seeing AI application. Take a look at the video, it's pretty amazing.
Navigate to my next meeting.
Your next meeting is with Juliet in Studio C. Would you like me to guide you?
Yes.
Are you starting from the lobby of Studio C?
Yes.
Pan your phone to map the room. Follow the audio breadcrumbs to conference room 1200.
Where can I sit?
Pan your phone to map the room. Table at 12 o'clock, empty seat located at 11 o'clock.
Hey, glad you're here. Let's get started.
It's just amazing. I love that we can build these kind of inclusive and diverse environments where everyone can participate thanks to all the advancements in computer vision in the end, right? That's awesome. If you want to get started with Azure Spatial Anchors, the SDK is available for all these platforms I mentioned, HoloLens, iOS, Android. You can develop natively, but you can also use this 3D engine called Unity, where you can develop cross-platform games and applications. And that's what I've been using, and most people are actually using as well that I know of. All right, that was a ton of stuff, huh? I'm very aware of that, but let it sink in a little bit. I will be also around for a few more minutes to answer any questions. So feel free to send your questions over, and we can talk about those. If not, like I mentioned, feel free to connect on LinkedIn. Just Google search my name on LinkedIn. Also, Twitter handle is on the slide. So feel free to connect there. And like I mentioned, I constantly keep on sharing these kind of concepts and, like ideas and actually proof of concepts, really constantly keep on sharing those. And I think it's an amazing time to be alive where we really see science fiction technology becoming a reality. And in part, it's already not sci-fi anymore. It's already here. And we can use it. And some parts were even beyond what sci-fi authors just imagined, right? And thanks to spatial computing devices, right? All of these devices, your mobile phone you have in your pocket, or you might have something like this and a head-mounted device. All of these spatial computing devices that can sense the real world around us, combined with the AR cloud that gives us this reference map to, bring and anchor virtual content. We're seeing all of these amazing use cases emerging. And the 2020s will be really about spatial computing, and we'll see take it off much further. So far, thanks for your attention. Take care, my friends. Be safe. And if you have any questions, it's time for Q&A.
Yeah, there are a couple of questions. Yes, Rene, there are a couple of questions. So there's one question saying, in your opinion, what are the current limitations, constraints that are inhibiting the widespread use creation of VR AR applications?
Yeah, a couple, I guess. One of them is, of course, the price point, right? I mean, if we're talking about these kind of device like a HoloLens, it's $3,500, right? And so that's of course more for enterprises and companies, and not really for end users and consumers. So that's one part of the equation. The other one is also the form factor, right? When I put it on like this, it's really nice. You can wear it for quite a time. I can wear it for hours actually without issues. You can also do it like this, right, where you can just open it up a little bit. But still, it's still quite a bit bulky and nothing you want to wear for the whole day, right? And I think that's really, when we're talking about AR scenarios, that's really the thing is like we need smaller form factors and we need a more approachable price point for end users. If we're talking about VR, we're already there in terms of price point, but the use cases for VR are more limited, right? If we're looking into training scenarios, it's great. But in the end, also, that's what all these market research company will tell you is AR is just the biggest one, and that will really, really take off, right? And so that's in the end what we really need to think of is like AR is providing us more value. At the moment, the dominant AR platform is really mobile phones like this here. So yeah.
All right. And in continuation to that question, there's another one saying is the implementation of 5G technology, or, rather the lack of it, like the network speed is one of the constraints that is inhibiting the creation of more VR applications.
I wouldn't say it's a blocker or something like that, but let's see it the other way around, right? Where we would say, okay, if we have finally real 5G, because most of the 5G we have these days, and it's the same here with Deutsche Telekom in Germany, right? Again, I have a 5G device here, but they're using frequency sharing with 4G. And so in the end, I get lower bandwidth than I have with LTE plus. And so that's kind of funny, but they label it a 5G because, it's by definition 5G tech, but they're just using frequency sharing at the moment on the same antennas. And so that's kind of, I hope, and I see that with other, internet service providers and telco providers across the globe, they're all doing the similar thing, right? Where they label a lot of stuff as 5G, but it's not the real 5G we're expecting. And so I hope they're not screwing it up, right? Because in the end, they might just mess up the whole term for marketing. Because in the end, it's providing us a lot of value in the end. Real 5G will have much larger bandwidth, 1 gigabit per second in the end. And then also low latency, which is really important, that you don't have a long delay between, the connectivity. And that will really help, especially for these remote rendering scenarios I've shown you, right? Where you can offload some of the heavy lifting, some of this hard processing into the cloud and build more lightweight devices. And so all of that will play a huge role. And getting to this kind of form factor, right? This kind of glasses size, 5G will be key for that as well.
All right. And another question asks if these apps are designed using particular toolboxes, like Unity,
Yeah.
for example.
Mm-hmm. Yes. So you can build these. What we're talking about when we're talking about spatial computing applications, and you can call it VR or AR application. It's in the end 3D programming, right? It's 3D applications. You visualize 3D content. With AR, you visualize the 3D content on top of the real world, and VR, you're fully in a 3D world in the end. And so the typical tools are 3D engines. Of course, you can start from scratch. You can use DirectX on Windows or OpenGL on iOS and Android, or Linux and so on, or Mac. So this is your underlying graphics stack, if you will. And then on top of it, you typically have 3D engines like Unity or Unreal, and they provide you great tooling. And you have this nice editor, right? Kind of what you see is what you get editor, where you can edit your 3D world really nicely, attach attach scripts to it. And with Unity, you can even write them in C#, which is really nice. And yeah, the dominant platform and the dominant tooling for AR and VR is Unity, with close followed by Unreal Engine.
All right. And there's one question from my side too. It is a bit related to the ethics of using AR VR. So the part where we saw your 3D profile being constructed given your photo, okay, given your 2D photo. So, if it is so easy to superimpose the 2D into like a proper 3D profile, then it could be easily used in, creating deep fakes or misinformed videos. So what is your take on that? Because Microsoft just announced a deep fake detector on the onset of the US elections.
Yeah.
So these two technologies, do you think they can be, uh, contradicting each other?
Yeah. So I've not shown any deep fakes here, right? As you notice, right? Just the 3D reconstruction. I know you know that, but just to be clear, but I think there are actually good use cases for deep fakes in the end. What we see mostly is really these kind of how to impersonate and do some bad things like porn or whatever, right? It's bad, of course, that's really bad. But there are actually legitimate use cases for deep fakes, and one of them is a service called Synthesia.io, and what they do is they make text to video. So their claim is, their tagline is creating videos as easy as writing an email. So basically what they do is you put in some text, and then they have some actors trained, and then it will generate a video where the actor will perfectly lip sync, say what you just typed in multiple languages, I think 30 languages or so. And so that is perfect, if you're struggling to create videos and you can make these kind of like my format, kind of like talking head format, you can easily create videos for marketing purposes and so on with these kind of services that are under the hood actually using deep fake technology, if you will, right?
Correct.
And it's a big issue, definitely, for sure, especially if we're looking at certain countries and elections and so on, where leaders are being deep faked in the end. And so that's a big challenge. And then what you mentioned is this deep fake detector that Microsoft is using. And yeah, it's impressive. It's actually using research paper or research from Technical University of Munich. It's called face forensics, what they're working on. So you can Google that. Face forensics is an effort from that group that also actually pioneered facial reenactment. And the same group is now working on face forensic, how to detect those deep fakes. And
Mhm.
of course, in the end, it's an arms race, right? Because as you know, these kind of networks are GANs, right? These are adversarial networks. So you can basically use the result from deepfake detection to make your
Mm.
deepfake generator better again. And so it's this kind of arms race, but still it's worth to explore, and it's worth to go with the effort, because the deepfake detector is working really well, what I have seen so far. And you need to make sure that you always catch up and make it updated.
All right. Yeah. Wow. I mean, I'm really looking forward to this futuristic workspace wherein, I would be able to access my screen, my machine sitting right from my desk and click some keyboard buttons there to power down my machine.
Yeah.
So yeah, thank you, Rene, so much. This was really, engaging session, and we could see a lot of use cases, lot of demos throughout. So it just 1 hour just flew by like this. Was not even aware that it was an hour long session. So absolutely, even our YouTube viewers are thanking you for the wonderful session, all the demos, answering all
Thank
our
you.
questions. And yeah, we look forward to having you again for our future events, for our boot camps, AI boot camps.
Sounds good. Thanks for having me. Take care, my friends, and have a great night in Singapore.
Thank you so much.
Thank
Good day
you.
to you as well.